Hello everyone and welcome to my today's lesson. Today we'll look at differentiation. It's a topic in Form 4, a very important topic which is always tested in any major exam, including KCSE. So this part is on differentiation, a part of calculus carrying 10 marks. We have a question divided in parts, and therefore it is very good that we are able to practice this area as we are it for the exam. So the equation of a curve is given by y is equals to x cubed minus 3x plus 2. Determine the value of y when x is 2. The gradient of the curve at x is 3. The turning point of the curve and their nature. So we start with the first part, the equation or to determine the value of y when x is 2. So if you're joining me for the very first time, kindly hit that subscription button, or you can give me a like. So the value of y when x is 2. So we're going to substitute that to our equation of y, 2 cubed minus 3x plus 2. And then just making sure that we obey the integers rule, we are going to get the value of y as 8 minus 6 plus 2, which is equals to 4. So the value of y when x is 2 is 4. Then the gradient of the curve at x is 3. So the gradient of the curve, we normally say gradient is given by dy dx. dy dx, so it means we are going to integrate or to differentiate our equation. So we have 3x squared minus 3. And at x being 3, we substitute the value of x being 3. So 3 into 3 squared minus 3. So 3 into 3 squared, this is 3 by 9, which is 27 minus 3. We get this to be 24. We get the answer to be 24. Then we move on to part C, the turning point of the curve and their nature. So at turning point, we normally say the gradient of a curve is equals to 0. And therefore, we had differentiated earlier. We now use that differential function, which we said it is 3x squared minus 3. So then we equate that to 0, and then we solve for the value of x. And if there are 2, we get the value of y that correspond to that value of x. So we get that we have, after factoring out 3, we get that we have x squared minus 1, which is a difference of 2 squares. So we factorize these, and we have x plus 1, x minus 1 is equals to 0. So on solving for x, we get x is equals to negative 1 and x is equals to 1. So we substitute these values to the original equation of y for us to be able to get the points. So when x is negative 1, so we use the equation. So we are going to have, we had x cubed, so negative 1 cubed minus 3 into negative 1 plus 2. And then on substituting that or putting that onto your calculator, you get the value of y to be 4. And therefore that point is negative 1. 4, that is one turning point. When x is 1, we substitute the value of y or x to the equation y. We have 1 cubed minus 3 into 1 plus 2. So again, we are going to get the value of y to be 0 when you substitute and that point would be 1, 0. So we have two turning points, negative 1, 4 and 1, 0. So it means this is a cubic equation, which is true. So it will have two turning points, either a maximum and a minimum, or a point of inflection, and so we test whether it is a maximum. We start with when x is negative 1. We're going to select two values on either side, on the left and on the right of -1. So we have -1 to the left, we have -1.5, and to the right we have -0.5. So we test these with the equation of the curve dy dx, which is 3x squared minus 3, and by substituting the value of -1.5, and we get this to be, so we substitute the value on the calculator, and then we make an observation on the values that we get of the gradient, whether it is negative or positive. If it is negative, then that line runs from left to right. If it is positive, it runs from right to left, and then we can be able to say whether it is a minimum point or a maximum point. So sorry for some confusion here. So we have 3.75, a positive 3.75 when x is -1.5, and negative 2.25 when x is -0.5. So the gradient of that curve would take that shape, and this is therefore a maximum point when the gradient changes from positive through 0 to negative. Then we test for x being 1. To the left we have 1.5, to the right, or to the right we have 1.5, to the left 0.5. Again, we substitute this value to the equation of the gradient 0.5, and we get the value of x is equals to 2.25, which is -2.25. That is 0, and then 3.75 positive. So the shape of this gradient will be running from left to right through 0, then from left to right, and this therefore a minimum point. So the graph that takes that shape is a minimum point. So we have identified the nature of the turning points. So we have two turning points, and their nature is, one is maximum and the other one is minimum. Thank you for watching. Hope you enjoyed the lesson. Make sure you're not left behind next time. Make sure you subscribe to my channel. You can share with friends, ask a question on the comment section, and don't forget to keep on revising. That is the only way to make it in March. Thank you for watching. Have a good evening.